Hi guys, welcome to another session on complex analysis. Today we'll be doing Cauchy-Riemann equations in polar form. Guys, thank you for the support you have received so far, and all the feedback, guys, that we are receiving has been positive, and we are very thankful for that, guys. Please continue to contact us, speak to us, and ask for help. Give us advice on how we can be better and stuff. But today, as I said, we'll be doing Cauchy-Riemann equations in polar form. Now, let us start by a beautiful record. Remember that a complex number in polar form is given by this, where our EI theta is called the Euler equation. Okay, so the conditions that hold for Cauchy-Riemann equations in rectangular form also hold for Cauchy-Riemann in polar form, and the conditions for Cauchy-Riemann in polar form are given by RUR. Okay, this has to be equals to V theta, and the second one is negative RVR is equals to U theta. So these two conditions have to be met. So these two conditions are the CR equations in polar form. Okay guys, these are CR equation in polar form. So this CR equation in polar form, guys, so we know that we can define a derivative in terms of the Cauchy-Riemann equations or the partial derivatives, and we can do the same thing even here in polar form, and it will be given by f prime at z is equals to, now we're gonna have e to the negative I theta. Now this is something which we'll always use. Okay, ur plus I v r. Okay, so this is going to be our derivative in terms of our partial derivative. So this is the derivative in polar form, and this is the derivative in rectangular form. So these conditions have to be met. Remember guys that they both have to be met. It means it also holds that they are going to be continuous, they are going to be what I basically mean is the sufficient conditions of differentiability also hold for CR equations in polar form. So let us have an example of a CR equation in polar form. Okay, let me check here. Let me try this one. Find the first derivative using the Cauchy-Riemann equations in polar form of f at z is equals to 1 over z to the exponent 4. This is 1 over z. Okay, so let us start by showing what is 1 over z in like that. So 1 over z to the 4, I can write this as z to the negative 4. This is going to be r to the negative 4 e to the negative I 4 theta. So this can be rewritten as 1 over r to the 4 cos of 4 theta minus I sine of 4 theta. Okay, so after defining this, guys, we can simply see that our u r theta is given by 1 over r to the 4 cos of 4 theta, and our v r theta is given by 1 over r to the 4 negative sine of 4 theta. It's a negative, guys, sorry about that. Now let us find our partial derivatives with respect to Rn. That so our our partial of u with respect to r is given by negative 4 cos of 4 theta divided by r to the 5. Okay, and our u theta is given by the derivative of that, which is negative 4 sine of 4 theta divided by r to the 4. And let us look at our VR. Our VR, the derivative of this is going to be 4 sine of 4 theta divided by r to the 5. And then our v theta is given by, so that will stay the same, negative 4 cos of 4 theta divided by r to the 4. R to the 4, sorry. I love this file. R to the 4. Okay, so we can check if whether the Cauchy-Riemann equations in polar form hold. Let us check them, guys. RUR must be equals to V theta, and negative RVR should be equals to U theta. So let us check. RUR is equals to V theta. Yes, if I multiply this by 1 over R, if I multiply this by R, it becomes negative 4 cos 4 theta divided by r to the 4, which is equals to that one. Okay, so we can say that therefore our RUR is equals to V theta, and our negative RVR is equals to U theta. Okay, I hope you are still with me, guys. I hope you still understand what I'm doing here. So let us find the derivative now. Now the derivative, as I said, of z is given by this equation that we have here, e to the negative I theta ur plus ivr. So it becomes e to the negative I theta, and then we have ur plus ivr. Okay, so let us have a direct substitution. E to the negative I theta, ur is negative 4 cos of 4 theta divided by r to the 5 plus I, and then v theta, vr is 4 sine 4 theta divided by r to the 5. Okay, so this can be rewritten as, take out a common factor, negative 4 over r to the 5, and we are left I theta. Okay, and we are left with negative, we take out a negative as a common factor, so it's just cos of 4 theta minus I sine of 4 theta. Okay, so let me write it well. Just remove this piece here. Okay, so this can later be translated to negative 4 r to the 5 e to the negative I theta multiplied by e to the negative I 4 theta. So multiplying the powers of the same base, we add the exponents. So I can simply write this as negative 4 r to the 5 e to the I 5 theta. Okay, which this is just equals to negative 4 all over r to the 5. Okay, in which if we use first principles, or we use the power rule here, we can see that its derivative will translate to negative 4 all over z to the 5, which is the solution that we get. Oh, I wrote r. Sorry guys, I wrote r. I must write z here. Sorry guys. Z to the 5, not r. Z to the 5. Okay guys, so I really hope that you understand what I was doing here and it makes sense. If it doesn't, guys, please do hit us on our social media platforms and do leave a comment in the comment section below. If you came this far, guys, please do hit that like button, and please subscribe and share the videos. For now, thank you very much, guys. See you on the next one.